Welcome to the video for the operation of the Loher 800 kilowatt wound rotor motor brush lifter's brake. The newer assemblies we now receive utilize the pinch boob insert brake model KFB 10.2 with 260 volt coil. What we're going to try to show you is the operation of the brake both mechanically and electrically. The focus is on the release of the armature and the application of the brake. Attention is to be paid to the rotation of the shaft versus brake position as seen by way of the air gaps. Air gaps were found to be set at 0.3 millimeters, which is the minimum spacing. They have been set to 0.8 millimeters for the purposes of seeing the brake operation more apparent. 1 millimeter is the max setting. The same type of operation can be seen at 0.3 millimeters as well. What you're seeing here is the operation of the brush lift motor and now stopping. You can see that the brake and armature return to a fully de-energized position after the motion of the motor shaft has stopped. This portion of the video is similar, just with the addition of this oscilloscope attached to view the AC line and the DC coil supply. What you see is that we have periodically marked the brake disc with permanent marker to allow for easier viewing of relative motion. Again, the air gap is set to 8 millimeters. Now we'll have a look at the oscilloscope and setup. We are using two channels of the scope. You'll see that channel A is connected to the output with a diode half-wave rectifier, and channel B is connected to the A and B phases in the motor junction box from the incoming connections from the brush lift motor starter that feeds the half-wave rectifier. Now we will see the start of the brush lifter motor. Notice the pull-in of the armature, and motion can now be seen on the brush lift brake with no mechanical friction. As you can see on channel A, we have the pulsating half-wave DC in red, and on channel B we have the full AC line voltages from A to B phases in blue. You will see that we have set up oscilloscope readings for effective volts DC measured on channel A and volts RMS and line frequency for channel B. As can be seen, we see about 260 volts DC effective for the DC coil and 580 volts RMS for the line voltage with respect to A and B phases. We will now set up for the brush lift stop operation. We will be putting the oscilloscope into a recorder mode. This will allow us to watch the flux collapse and decay of the DC coil voltage when power is removed. Now you will see the stopping operation. Note the brake disc seems to move slightly towards the armature plate, followed by the full travel of the armature plate traveling to the de-energized position once shaft motion has stopped. Now let's have a look at the oscilloscope capture. The overshoot spike seen on the AC waveform we can assume to be the result of inductive kick when the contactor opens up. The time from this effective zero of both line and zero and DC effective is approximately 320 seconds. Using the fairly simplistic assumption of having a nominal dropout at 60% of voltage on the coil and equating that to time, we'd expect the coil to be released around 192 milliseconds and the spring snapping the armature to the off position. Based on this and evidence that can be seen on the gear teeth, we believe the armature is being impeded by the tightness of the motor and the brake meshing. Thanks for your time, and I hope this video is good enough to illustrate that. Thanks. Welcome to the video for the operation